Speaking of tools, you're using some very, very interesting techniques like the two-photon microscopy and the calcium sensors in the brain that kind of help us track brain activity on a large scale or on a cellular scale, and other tools that you probably will share with us. But how do you employ them to study, for example, the things that you're studying, memory?
I think this is well, it's one of the tricky things as well in science or in neuroscience. It's very much technique driven. I think there's lots of questions, and people have all kinds of ideas on what one would like to study and how one would like to study it. But very often we simply lack the tools, right, to go in there and to record cell activity, neuronal activity at large scales. We just don't have the tools to know exactly what's going on at synaptic level. And it's getting better, and often a new technique comes up, and suddenly you see all these questions are starting to pop up as well, and almost looks like these questions are new, but they are not. They suddenly can be addressed. And so, we are doing the same. We apply new techniques when they come about, or we try to help a little bit in the development. But my lab personally is not very, pioneering in that respect. I was a bit at the forefront, I think, when two-photon microscopy started to really take off and started to be applied in vivo. So, I was fortunate to experience that firsthand. And it really showed me the power of really seeing things, live happening. That said, there is always this uncertainty principle when you look at the brain. Is this really, what is going on when you don't look at it? Is it generalizable? Can you apply it to all systems? Let's say in cortex. So yes, these underlying doubts always remain. Same with measurement of activity with calcium imaging. Calcium is an ion that a flux of ions that is important during activity, but it's not showing everything, and it's usually not well showing what's going on under the hood, as one says. Right, there is a lot of computation perhaps happening in a neuron or in dendrites that remain invisible. I was very excited when I saw that the tools coming up with which we can image synaptic activity, because that really gives us a first possibility or glimpse of how activity of a neuron is related to the activity of synapses, which we so far could only do with electrophysiological measurements, but we couldn't really, not really do it at the synaptic level. And we could only infer that particular synapses or a number of synapses was active. So yes, lots of exciting technical developments, both at the physiological level and at the imaging level. And collectively, I like to term these optophysiology. I think that sort of that groups everything together, and all the tools like optogenetics, calcium imaging, physiological recordings. I think altogether would be optophysiology, which is the new sort of level of techniques that we have right now.